Okay, hi guys. So in this lecture, we'll be continuing on seeing characteristic of our elimination reaction, and before that, let me give an example on the elimination reaction only. So the example is as follows. So suppose we have this alcohol, where we have something like this. OH and a substituent here. So what will happen when we actually pass it on, let's say, concentrated H2SO4, and we actually heat the reaction? Heat is very important because as we saw in the last lecture, it is a the delta H for this reaction is positive. If you don't know much about delta H, you can see more on the delta H in my physical chemistry lectures, so don't worry about that. So if delta H is positive, just remember that it's an endothermic process and we have to give the heat for the reaction to take place in the forward direction. Okay, so what will be our intermediate? Intermediate would be nothing but something like this and this. So what all products can be formed? We are not talking about the major concentration, major yield or minor yield. We are just talking about what all possible products can be formed when in the next step, which is HSO4 minus again attacks on any acidic hydrogen present in this compound. So what all products should be formed? One product that can be formed is this one. One product that can be formed is obviously this one, and the third one could be this one. Okay, so these are the three products formed. So if you talk about the number of alpha hydrogen, in this case it is 6 plus 4 10, and in this case we have 2 plus 3 plus 1, which is 6, and in this case we have 2 plus 1, which is 3. Okay, so obviously this would be in more yield, but we are just talking about the potential products. Okay, so this was just an example I wanted to show you, that in this example three products can be formed. Obviously this would be in major yield. Okay, so let's talk about the characteristic of this reaction. Characteristics of this. So we have, whenever I have given you any type of reaction, any sort of reaction, first we talk about the mechanism as to how it happens, what is the rate determining step, what is the energy graph, what is the equation, then we talk about the characteristic of the reaction. This is the flow we'll be following in all the future coming video lectures in chemistry, especially in organic chemistry. Okay, so rate is proportional to the concentration of alcohol. Rate is proportional to the concentration of alcohol, more the concentration of the reactant or the substrate, better substrate, more will be the rate of reaction, concentration of alcohol. Okay, second point is it is an even reaction, or we have just seen the in the past lecture we saw the grouping of elimination reactions E1 E2. Okay, so it is a even reaction. It is a E1 reaction, or I can also say it's a unimolecular elimination. Okay, third point I can say is the formation of carbocation is the rate determining step. What is the carbocation here? This was the carbocation here. So this is an intermediate over here. So formation of carbocation is the RDS. We saw this in the graph as well in the previous lecture. Okay, so more stable the carbocation, more is the rate of reaction. Simple. The more stable the carbocation, more is the rate of reaction. Okay, let me come to the fifth point. Fifth point is driving force for this reaction is high temperature. As you can see here, we heated this reaction in presence of concentrated H2SO4. So driving force for this reaction is heat. Okay, sixth point is actually what happens at high temperature is distillation of alkene actually takes place. Okay, so I'll just explain you with an example that suppose we have something like this. This is OH and this is H, and if we provide it, and we are just comparing the boiling point of these two compounds. So the boiling point for this alkane is actually 80 degrees Celsius, and boiling point for this is 161 degrees Celsius. Okay, so at high temperature, distillation of alkene actually takes place. I'll just write it in blue. Okay, at high temperature, distillation of alkene takes place. Okay, now let us look at the 7th characteristic we have. So at high temperature, it favors elimination reaction because of increase in entropy. So for all you guys who don't understand entropy at this point of time, no worries, you can skip this characteristic. It is very significant to no use in any of your problem solving skills. You can refer to my physical chemistry lectures to know more about it. So at high temperature, it favors elimination reaction because of increase in entropy. Okay, so one important point and the last characteristic of this reaction is rearrangement is possible in this reaction. Okay, so we'll get various combinations of products, and you have to apply your brains, and you'll have a lot more fun in actually deriving what all products can be formed in a even elimination mechanism. Okay, so rearrangement is possible in this reaction, and why? Because of the formation of the intermediate tricarbocation, which is in the RDS. Okay, so let's take a look at some more examples. Suppose we have something like this, and this is passed on in H plus with, and we heat it. So obviously when I write H plus and we heat it, it obviously means that out of all those reagents which I mentioned in the last lecture, we are using one of those reactants, just as H2SO4, H3PO4, Al2O3, KHSO4, and something like those, right? So I'm not explicitly writing those reactants, but that is understood. Okay, so what will happen is we'll get a positive charge at this carbon atom. Now what will happen is you can have 1 to H plus shift, okay, to form something like better H minus shift, to form something like this. Okay, and this will get a positive charge, and only one hydrogen remain here, and that hydrogen actually moved on to this carbon atom. Okay, so now what will happen is, again this compound can actually undergo 1 to CS3 minus shift. Why I'm saying 1 2 here? Because you can count the number of carbon atoms from here in this case, and you can count the number of carbon atoms from here in this case. So it would be basically 2 3. It's correctly written, it is 2 3 CS3 minus shift. So what will happen is we'll get a positive charge here, and CH CH3 and CH3 here. Okay, I hope you are understanding why this shift is going into the forward direction, because if we calculate the number of alpha hydrogen here, which is, these are only 2 alpha hydrogen in this case, this compound or this carbocation has actually 3 alpha hydrogen in this case, and this carbocation has actually 3 plus 3 7 alpha hydrogen in this case. Okay, so this is going into the forward direction because of the increase in stability because of the hyperconjugating structures. Okay, then it can actually have some reaction. We can have products like either this because of the removal of this hydrogen or this alpha hydrogen, or we can have a product something like this. Okay, okay, so I hope this would be the major compound and this would be the minor compound with 12 alpha hydrogen in this case, and this is the major compound, this would be the minor compound. Okay, so let's look at another examples. So let's say we have something like this. This OH, and in presence of H plus we heat it. What will happen is this would get a positive charge, positive or carbocation here, so this would be the major product. Which one? This one would be the major product. Okay, and the second one is, suppose we have something like this. Now in this case we again provide acidic medium and heat it. So what would be the product? We can have 3 products here. The first one can be something like this, second one can be something like this, and third one would be something like this. But again you can see that these products are same only because I can rotate it and through this plane 180 degree, so this will result into the same compound. So this would be the major compound. Why? I hope you can guess why. Okay, so we come to the end of this lecture. In the next lecture we will be dealing with some more examples on the even reaction or the elimination reaction. Till then, good luck and goodbye.